So we're going to touch on. And this week, we're going to be talking about technical transformation. We also have a couple tips about measuring multiple line, measuring an angle, and this is your question on how to use the question. Didn't want to do that. So I thought we'd do something a little different with my son, and we're going to have a piece of this, and we'll look at the time and more to do it next time. This is where the work on what's happening as you think how it happens, and then kind of add some mathematics to it. Start to do a little bit of that, and I think you want to definitely have a few things in the game to have. So,
the unit that like I said, the units you're going to work, the lessons you're going to work on have to do with measuring length and angles, which you guys I know can do that pretty much on your own. Most students can do that by now. And transformations is our focus today. So I didn't put an essential question down. That what I want that to be is I want you to be able to describe the different transformations. Okay. That's what I'm doing. Okay, there is, but I told you what it was, and I put it in there. Describe the different transformations. Sorry, the typing is not working very well. Okay. So that's your essential. That's your essential. It's not really a question, but that's what I want you to do. I want you to think about what the different transformations are and be able to describe what's happening with those transformations. Okay. So if you're on the other end, make sure you give me a check mark when you have this written down. So those of you that are coming in, two or three of those little papers. Okay. So we have that down? Everybody's taking notes, correct? I'm hearing us talking still through this whole time, and I'm not sure you got the notes down. Don't be the one person that makes everybody have to turn them in and get actually have me grade them instead of just giving you the 10 points. Okay? All right. So there's a bunch of vocabulary that we're going to be using either through this next week or the week after with transformations. So let's get those down. We will space to kind of go back and define some of them. You may have to define them as you're going through your lesson. The lesson's online. Some of them we may get defined here. like most of this is ready. Couple more seconds. Okay. All right. So transformational geometry. Don't worry about the directions here yet. Quite yet. The transformational geometry is one kind of geometry. There's several kinds of geometry. And Euclidean geometry, which you went through your lessons last week, then we describe that. And that's what we call it static geometry, which means it doesn't involve movement. And then we have transformational geometry, which means the geometry is movement. And most of the time when we're doing this geometry in the real world, there's some sort of movement to it. So it's that's when you do the geometry of movement and movement. So that's what we're going to be looking at and talking about transformational geometry, because that's kind of what used to be happening in the real thing. So what we're going to do is we're going to take that pattern paper, that's what this is called, that's the paper that's in between the numbers and stuff, so they have to make one, okay? So it's a kind of black paper. And what we're going to do is we're going to take that, so we're going to take our patty paper or wax paper, and we're going to just place it on top of the very first coordinate plane, okay? And we're going to trace the shaded figure, because that's going to be our original figure. So just trace over the top of it and then shade it in with a color of some sort so we know that that's the original figure. There's color pencils in the box, most of the boxes. There should be in just got all the boxes, so. Yeah. That you have a shading outside the side is the right, the correct color makes the right shade. And then you look at the other side and see that you look at the colors, you can tell which side that is and back side then. Okay, questions? That would be a good idea. Yeah, it would be a good idea to write the letters on, label the corners on there. That way you can see where they match up on the other shapes, because we're going to talk about how those get labeled and stuff like that. Okay. Everybody pretty much ready to go. They've got this trace shaded. You've got the letters on there pretty much. Okay. So what you're going to do is you're going to take this paper and basically, if it's laid on top of the first one, what do I have to do to get that shape to match up with the other shape in box number 1, or the quadrant? The quadrant I put a number 1 in it, but it's really quadrant 2, isn't it? Hmm? Okay, so think about it. Just go ahead and do it. And see if you can get this one to match this one, and what is it that you did. We're going to do kind of one together, and then we're going to talk about it. And I'll let you go on your own for a little bit after this.
Everybody get that? So what did you do?
What did you have to do with your paper, the patty paper or the wax paper, to get from the shape in the first quadrant to problem number 1, which is in the second quadrant? What did you mean by folded it? Show us. Oh, so you just kind of took the paper like this and folded it over like that? Okay. Everybody see that? Okay. So that's good. You fold it over like that to make that work. Now, when you folded it, did you have it laying on this? And where does the fold line match up to anything on here? The darker line? Yeah, so that's one of our axes. Okay, so if I have this sitting on here and I folded it, if I did actually fold it, I folded on that axis. If I fold it over on the axis where that is it going to match exactly the other one if I fold on the axis? Everybody try that. Lay it back down. Lay it back down on the original one. And try to fold it on the axis. See what happens. Does it come out exactly on the other one? It's supposed to because we're not flipping with our folding. Does that work? Okay. So there's a fold there, and that fold is on the axis. Well, I wonder why when we flipped it over, when we folded it over, why did that come out exactly right? Flipping and think about it. Okay, why did it come out? Why was it important to hold on the axis? Well, if you think about it for a second, why was it important to hold on the y-axis? I know some of you guys have a different word for the fold here. We'll talk about that in a second. Talk with your group a little bit about what you noticed. Any qualities or characteristics between this one, and why was that, and why that folding it on the axis was important. All right, so you guys all came up with some really good things here. So let's talk about this. What did you notice in this situation? Why was it important to know that the fold had to be on the y-axis? Several of you said it. Justin, go ahead and share it. Yeah. Every single point on each one is exactly the same distance away. So like the very first line here on the original one, all those points on there are 3 away from the y-axis, and that same line on the other side is 3 away the other direction, isn't it? Okay? So this is a characteristic of this, what we're talking about here, is that all the points are, whatever that fold line is, okay, that whatever that fold line is, that the points have to be equal distance away from it on both figures. In this case, the fold line was the y-axis. Does it always have to be the y-axis? No, it doesn't. Okay? It doesn't have to be the y-axis. But there is always going to be that, kind of what we're calling it now, that fold line. It's not a fold line, but we're going to call it that for right now because that's what makes sense to us, is what we're working with, okay? So that's the first thing. Now, some other people use some other words. I like the word you guys used back here. What was the word you guys used for me? The mirroring it. Okay? It's a mirror image. M-I-R-R-O-R. Like you look in the mirror, right? Okay? And so when we look in the mirror, what do we see? What's it called though? A reflection. So guess what this movement is called? Reflection. So in reflection, you might add this to your pieces of reflection. In reflection, you're reflecting across a line, okay, a chosen line. In this case it's 0, right? So y equals 0. And all the points are equal distance away. So everybody stand up, and we have to find a partner. So we have to like okay. So later that person says get this partner. Okay, so you guys have been partnering with the company. So partner A. They should do something to be able to tell you that they can be because you should do one hand, okay? You can put your hands on your head, you can one of your 2 hands, okay? You could gesture to both hands, but I'm not going to say that, okay? All right? Okay? Yeah, that's what we're going to do, yeah. Okay? But, so partner A, we thought what we're going to do, just let's get stationary for right now, so it's not moving like it's just like that, a great idea. So partner A, do some first pose that your arms have to do. Okay? I know we're going to silly guys, that's okay. Because part of the time it's really silly like that. Okay, be silly like that. Now, partner B is going to be your instruction. As you do, it's going to be your flex down. Okay? There you go. A couple of you guys are kind of
reflection.
You get a reflection like what we just did,
Yeah.
right? See that, you can see it. If I don't know if you can see it. Look, everybody, I see it. Oh. Yeah. Did you see what I can see that? Okay. Is everybody see that? Third left hand is next to my right hand. So I got it. Flip it over, right? Okay.
All right, so then sit down. So when we do this, what we say is we reflected the first figure over the, in this case, the y-axis, right? So if I want to describe the movement, I say I reflected the figure over the y-axis, okay? And so that's what says, how might you explain to somebody else how to get that figure, write down that explanation. So what you write down is the figure was reflected over the y-axis, okay? Or you say y equals 0, because that's what that is. So, yeah, just on your notes. Okay, so that's problem number 1. Then, when you label the new figure, you use the same letters and make sure the letters match up to where they were here, over here. So and you use a little apostrophe sign after it. We call that prime in math. So you just put A with a little apostrophe after it for that figure. Okay? So we know it's the same figure, it's exactly the same figure, it's just in different place and different, maybe a little different direction. Okay? So on your paper, label it with that. And then what I want you to do is actually do these steps for the rest of the figures on figure 1, the first quadrant. And you don't have to fold, you can fold if you want. Try that for all the figures we're going to talk about in the second, okay? We're going to try moving that for all the figures and describe them. Note down what your movements are as you go through, right? Don't forget. What was the movement? It's always figure 80, the original figure to the next figure. Are you from the original figure to the next? Yep. Okay, so what was the movement? Write it down. always making sure you write it down in the minutes. So just do it, write it down. We'll talk about how to do something that you can read off. Okay, so this and this to this.
That's why I'm doing that last minute.
Okay. All right. So most of you have done most of these now and tried some different things. So how did you get from the original one to the number 2, which is in the third quadrant? Okay. You said, okay, so instead of saying flip, that's called a reflection. So you reflected it across the y-axis, then you okay, it says flip. Okay, group help. Group help. She's reflected it across the y-axis, then she's going to, oh, she did. Someone else help. Reflected again across the x-axis, okay? Okay? So you reflected across the y-axis, reflected across the x-axis, and you got that. Did anybody get something different? So I think Cody had differently, right? Oh, Cody rotated it. How many times under rotation is it? Okay. So yeah, I get that she said a couple things and there was different. You can do both things, right? So I wanted to get both pieces out there. So we can rotate it. Now where we rotate, just like we have to have a reference point with our reflection, we have to have a reference point for our rotation. So what was our reference point for our rotation? Okay, so we were rotating around the origin, and how far did we rotate it? 180 degrees, right? Because it started here and it ended up over here, so it goes to 180 degrees. Okay? So rotation is when you're turning it around a point. You guys getting that? Turning it around a point. Okay? And you need to be able to describe that point as well as how far you rotated it. Okay? And the rotation is just one move, whereas the reflection had to be 2 moves, right? Pardon? Okay. So, how was the last one?
So the last one, there's just one from here, you have to flip it over and down, and then flip it to the side, and go upside down again. There's an rotation to the side, then flip it.
Okay, which one? We start from the original, right? Okay, let's listen. Starting from the original, you rotate, okay. We don't rotate to reflection, you reflect it, okay, across the what? Rotate, reflect it across the x-axis. So now you're taking it, so now it's upside down like this. Okay?
And then you go upside down.
Then you go upside down.
You flip it to the right.
Flip it to the right, but across the what axis?
Rotate it to the right.
Okay, you want me to rotate it around what point?
So, y-axis, I think. Yeah.
Okay.
Oh, I thought you were going to look
Oh, okay. Okay. So you flipped it, so it's like this, and you rotate it.
to the right on the y-axis.
Where's the point? If you're rotating, you need a point.
On
Point by the what?
D1.
On point B. So point B is this point right here, right?
And
So I'm going to rotate it on point B. Does that work?
yeah.
Move it? Is it right on top of it?
Yeah.
Really? Okay, so I have to get it. So let's think about this. Okay, I have to think about it. I got you. Somebody else, what you do? What did you do? I have to get from the original one to the one in the one quadrant that's 1.3. What do you do? Okay, rotate around what? Rotate around what point though? I can rotate around this point right here. That's not going to get it. That's where you want it to be. But they get that same. Yeah, because it's a specific point you're rotating around, you can just, yeah, you just connect where are we turning it? Everybody's saying rotate and flip. Right? And now you got to get specific. So I want you to work right now and figure it out. What is my reflection? What's the line of reflection? Where you reflect. We use the x-axis, the y-axis, and different lines. And what's my point of rotation? Is it the origin this time, or is it someplace else? Everybody work on it right now. So we're working on figuring out for problem number 3, how to get from the original one to that problem number 3 in the 4th quadrant, and trying to be very specific about what we're reflecting, what line we're reflecting over, and what point we're rotating on.
your papers. Right, you guys are starting to see the more specific piece of this, and that's really important as we're doing this.
We have several ways now, and I want to try all these different ways. We have several ways now to get from the original to the third problem, is the one in the fourth quadrant. Okay? So let's have this group over here share what you guys found. Okay, so let's everybody put it back to the original. And they're going to follow along your direction. So you have to be very specific so they know where they're rotating, that kind of stuff. And your group can help you out. I'm not trying to put you on the spot. Your group can help you out. Okay? So it's your whole group. Okay, so your point of rotation you're saying is point C? Okay, so everybody put your pencil on point C and rotate it around point C. Put the pencil point on there. And rotate your pad of paper around point C. And how far are they rotating? 90 degrees or? Okay. Did everybody do that? Get your pencil. So you're still in your original box. Put your pencil on there at point C on the patty paper and rotate it 90 degrees. Okay. So everybody did that? Okay, now what do you do? Okay. Yeah. Actually, if we actually had it really pinpointed in the word 2 minutes and have an error, we could do that. So, okay. Does everybody get that? Did it work? Did you make it work? Okay. So did you guys do something different? So do that. What you guys do? So you found the point of rotation was point C. Okay. How about let's say this perspective here. What did you guys come up with? Okay, so everybody put it back on the original. Put them back on the original. So we're going to do exactly what this was telling us to do. Okay, so I'll see everybody back on the original one. Okay. Good. Okay, you said reflect on the y-axis. Okay. I think so. You guys ready? Rotate 90 degrees on the origin. So put your pencil at the origin, which is 0, 0, and rotate the paper 90 degrees. Okay, let them get that first. Okay, go ahead. Next up. Slide it 6 squares to the right. Yes. Okay, did it work? Did it work? Okay, that's what you're going to do too, isn't it? That's what you described? Okay. So why is it 12 and not 6? Yeah. Okay. All right. Everybody got that? So I didn't quite answer there because it wasn't quite far enough. You have to go a few steps further, right? Okay. How was the bathroom? How did you guys have something different than you do? Okay. All right. So we have another word. We have reflection. Right? That's like the flip. We're going to work with flip, right? We had rotation. Then you said slide, and we use the word slide, but that's also called a translation. Okay? It's also called translation. Okay? So, Here's what we're going to do. We've built all these terms, and we've had kind of some fun. Also had some little bit of fun by doing some of this kind of stuff. I want you guys to actually try the last couple and be very specific about your movement. But before you do that, I want to just wrap up one quick little thing, which is there's a couple other characteristics we need to add to our notes. One of the things that, again, we were very specific on was what? We were very specific on like the point of rotation, the number of slides, the direction it slid, right? Also the line of the reflection line, right? When we're describing everything. So those are very important. So that's something we need to make sure you're very specific about, like on a test or in your work. Okay? Because you should be able to tell me very specifically what to do, and I should be able to repeat that on my own paper, even if I don't have what you have in front of you, right? Okay? So first you need to be very specific about the points of rotation, the line of reflection, and the direction and the number of places you slide, the length of the slide. Sometimes that slide could, in fact, let's do this one right here. We're going to go from this, actually from this original one to this one down here. We're from this corner here, we're going to from this one to this one down here. So let's talk about the slides on that. Just quickly do that. Be very specific, write down this is what the slide is.
Move it to the left. 6 squares to the left. And you bring it down.
Alright, so most of you guys have figured that out. We wanted to slide the diagonal thing initially, right?
Yeah.
And does that work?
Maybe.
In terms of being able to explain to somebody else. Well, what you have to do is you're going to explain to somebody else.
Plus, you have to move the figure to the left 8 squares.
Okay?
And then you have to move it again to the left 6 more squares.
Okay. So altogether you moved it to the last 14 squares, right? Okay.
And then you go down 6 squares to get it to where it's at on the quadrant.
Okay, so instead of just sliding it at the diagonal, you moved it over to the left so many, and then you moved it down so many, right?
Yes.
Kind of like when you're trying to figure out the slope of an angle, or of a line, right? The overs and ups and overs, you have to count, right? All right, so the reason I wanted to do that so you knew that you had to do it that way for the slide, for explaining the slide, or the translation. Now, did the figure ever change from one to the other? No, it was exactly the same figure each time, wasn't it?
Yes.
Okay, and so that word isometry means that all the side lengths have to match up every time, but the figure is not changing. So when we have a rotation, a reflection, or a translation, we have isometry because the sides match up. Okay? So I'm going to go back. We talked about transformation. That was moving, the movement of things, right? Wherever that movement was. We talked about reflection. We talked about isometry, rotation. I put reflection up the second time so you can cross that off. We talked about translation. We did not talk about dilation. We're not going to right now. We're just going to talk about those. But be prepared for that, yes. Yes, so it has so it's similar to the other one, but it's just enlarging it or making it smaller. Yeah. Okay. All right. So there's the specifics about how we can do the dilations and like that we're going to need to know, but we don't need to know that for this particular lesson for this week. All right. Know a whole lot about that. Please make sure you go back and when you go through your lesson, fill in some of the holes that we don't have. There's going to be some holes in your notes. So make sure that you have your notes in front of you when you're doing the lesson and fill in some of those holes. All right? Questions about that? Okay. Please help me make sure it's cleaned back up. If you have extra copy paper, put it back up here on top of the box. Your name tags are up here. If there's other stuff that's around, and get rid of the cutting paper that you use into the trash can. So basically, come up and clean up your area.